Okay, here's the plant chemistry screen. Everything is in mhos, which is the inverse of an ohm. Ohms are measure resistance. Mhos are measure of conductance. These are micromhos, which is a millionth of a mho. The big thing, the sample temperature is 25 degrees Celsius or 77 degrees Fahrenheit. This is critical as this will affect your analysis results. All your pH probes do temperature correct, and your conductivity probes will temperature correct, but still a really good idea in operations to maintain the 25 degrees Celsius in all your water sample. The large part of this is coming off the condensate pumps. On the whiteboard we kind of showed where these samples were coming from, and this is where they end up. You have your pH, cat conductivity, which is the measure of the anions in the water. All your boiler water treatment chemicals have been stripped out. Discharge O2, this shows air and leakage coming from your surface condenser, piping systems, anything under vacuum. Down here we have our amine control. We are injecting ammonia hydroxide, trying to maintain this range. You have your deaerator specific conductivity coming in. This is a measure of all the dissolved solids in the water. Then you have your deaerator oxygen. This shows oxygen coming in, oxygen coming out. This tells you how well your deaerator is working. You have to play with steam temperatures or venting to make sure this is running correctly. Economizer inlet, you have your pH, cat conductivity. Again, all the boiler water chemicals have been stripped out. It's just looking for any anions. Hydrazine, this is oxygen scavenger being fed in. Action levels, this is how long you have at what range to correct the problem. 1 is pretty minor, 336 hours. Number 3, 8 hours. If you get down below 7.5, you shut down immediately. You're doing tremendous damage to the boiler metal at those temperatures and pressures. The big one is your boiler drum water. You have your pH. Normally stay in the range, 8.7, 9.6. I can see if you action levels, you get 8 to 7.5. You got 8 hours to correct the problem. You have your specific conductivity. This is all the dissolved solids in the water going in. Cat conductivity. This is all the anions, all your boiler water chemicals have been stripped out. We have sodium. Another thing we look for is chlorides and sulfates also. They can cause intergranular corrosion, stress cracking, and turbine blading along with the sodium. So those 3 items have to be very, very low in the water. You can have problems in your turbine blading in the future. Also at higher pressures and temperatures, they're a lot more volatile. They will carry over. Silica is another big one that at higher temperatures and pressures can cause plating on your turbine blading, lower efficiency as it builds up deposits on the blades. Feed water 5, this is all the water going back to the deaerator from all the feed water heaters. Just making sure that no contaminants have come in. And down here is your aux boiler chemistry, which is only used for plant startup.